Good evening, everyone. We are going to be going over the next week's work on constraints. So we have a PowerPoint presentation to go over. It's about constraints on a table, and it's the material that's covered in your text in Chapter 4. What are our objectives? We're going to explain the purpose of constraints in a table. We're going to distinguish among the primary key, the foreign key, attributes such as unique and the function of check and the not null. These constraints are all different constraints, and we need to understand what situations we use these in and how to invoke them. We need to distinguish between two types of constraints. You can have them either at the column level or at the table level, and it's important that you understand the distinction of how you create those and what situations they're appropriate. When we create a primary key, it'll usually be a single column, but occasionally there's a composite primary key, and we'll go over what the mechanism, what the syntax is to create them. You can also create foreign keys. Foreign keys are usually keys that are contained in another table, especially when we use the many-to-one relationships. We'll learn how to create a unique constraint and the check constraint. Those are both very powerful capabilities. Finally, we will talk about how to create a not null constraint and how to include constraints when you create a table. We'll cover how to disable and enable constraints and how to drop a constraint using the drop command. First of all, what are constraints? They are a set of rules that we use to ensure accuracy and integrity of our data. We can also use constraints to enforce some business rules, practices, or policies. They're not just technical constraints, but they're also business constraints. They help us keep our data consistent and accurate. What are the different types of constraints we have? Well, we have a primary key and foreign key constraint. The primary key identifies each record. So if you have a file that has lots of rows, you need to find a way to be able to select certain rows based on criteria. And if you have a primary key, that's the way you can select rows, certain rows, sub portions of your file. And the primary key cannot be null. And it's the way we identify unique records. So it cannot be null, it must be unique. A foreign key is usually the key on the many side of a one-to-many relationship, and it ensures that values exist on the one side of the relationship. Unique means that all the values must be unique, but it does permit you to have null. So I guess you could consider that if more than one row has a null value in the unique, that you could say that those might be equivalent, but they're not. That the policy is that you can have nulls in a column that is specified to have the constraint of unique. Check is a very powerful constraint. You can make sure that a condition is true before the record will be added. For example, in our application, the ship date has to be later or equal to the order date. You can't ship a product before the customer ordered it. A not null, if you have the constraint not null, then that column cannot have null value, so you cannot add a row with a column that has a not null constraint unless there's a value in there. What are the naming considerations for the constraints? What are the policies? You can use an optional constraint keyword when you're creating a constraint to give it a name. And the reason you might want to do this is sometimes later on we want to modify constraints or do special things with them. So if a constraint has a name, then it's easier to be able to access it later on to modify it or to alter it or to delete it. If you don't specify the name, then the server will assign a name to it using a default format called sys_C for constraint. And then it just sequentially numbers them to make it unique, so they can look very arbitrary. So if you want a naming constraint to use the constraint keyword when you create the table, and then you assign the alias. You can also let the server assign them. But it's always easier if you assign the name yourself. So we'll go through a number of examples. For conventions, these are not required, but it is common practice that when you name a constraint, that if it's the primary key, you use the column name underscore PK. If it's a foreign key, then the column name underscore foreign key. If it's unique, then the column name underscore UK. If it's a check constraint, underscore CK, and if it's not null, an underscore NL. That just makes it much easier for you to give names to constraints that are on columns. There are two times that you are allowed to create constraints. Most commonly, you're going to do it when you first set up the table, because you should, when you're creating a database, you should know what the table is going to be used for and would know what the constraints are, like the example we used a little while ago about the order date, the ship date being equal to or great or after the order date. You have to you have to have an order before you can ship it. But you can also modify a table and add constraints then. And there are two places that you can do them. You do it at the column level or the table level. We'll talk a little bit about what the difference between those are. The general syntax is in the column level approach. If a constraint's being created at the column level, the constraint applies to that column, to the column that you specified. So when you're writing your query or your code, you give the column name, then the keyword constraint, and give the alias, the name that you might want to use later on, and then the type of constraint. Is it not null or unique or primary key, whatever it is? Here's an example. We're creating a table called order totals, which does not exist up until now. And it's going to have in it the order number. And now we're going to specify, if you look carefully in that code, we're going to specify where that order number comes from. We're going to have a constraint on it that the primary key is, which we're going to name, give it the alias order total primary key. And then the other column that's going to be in this table is going to be total. But total doesn't exist. So in order to tell SQL how to obtain the data for total, we're going to say that it's done as, we're going to do a subquery selecting the order number and then sum the paid each times the quantity as the total. So we're going to calculate the totals on the fly right here to be able to create the second column. And this all comes from order items. In order for order items to be able to do the paid each times quantity, we have to be sure that all of the data is already in order number order. So we have to say group by order number, and that way the data will be in a compatible format for SQL to be able to create your constraints. So that's an example of how we do that. If we look at it and we select star from order totals to see what that statement up there created, we can see that the order numbers are in order, ascending order, and the total, some of them is just, they just ordered one book and just ordered one copy. They might have ordered just one book and multiple copies, or they might have ordered multiple books and one or more copies. But the total will be the total amount of the that order number of all the books in that order. So let's look at the syntax of constraints. You can create a constraint at the table level, which means that you're going to create the constraint after you've defined all the columns in the table. So you're going to do your syntax to create your table with all the columns, but then you're going to add at the end of the creation, you're going to add the constraint type. The only one that you can't do this later for is the not null constraint. The not null constraint is supposed to be created at the column level only, so you have to do that up in the initial definition of your table. If you need to define a constraint that involves more than one column, you have to do it at the table level. After you've defined all the columns in your table, then put the keyword constraint and followed by the name, followed by the type of constraint, whether it's primary key or unique or whatever, and then the name of the column or columns that the constraint's going to apply to. And there's your syntax for it. Here's an example. So we're going to create a table called customer total. It's going to have these columns: customer number, last name, first name, total. Then we're going to have constraint, the customer total primary key, or CT underscore primary key, as the primary key, which is going to be the customer number. As this is how we're going to create the data for this table. Select customer number, last name, first name, total from customers. And remember, from our joins, in order to get these data together to be able to calculate these totals, we have to align the data together from multiple tables. So we have to get data from customers and order items and orders. So that customers, orders, and order items that all have to be joined like we did earlier. And then when we do that, we can populate the data in this new table that we just created called customer total. That'll have the information that we want to have. It's going to have those 4 columns: the customer number, the last name, first name, and the total amount, dollar amount of the order. And so this succeeded. Let's see what data we get out of that. Here's the example. So we've got customer number 1005, and here's the name, and here's the total of his orders. Now you notice that the customer numbers are no longer in sequential order because we didn't order by. So they're just coming in the order that they were entered into the table initially. Enforcement. All constraints are enforced at the table level. If the data value violates the constraint, that row will be rejected. It will not be created. So constraints are enforced when you try to add data to a table. All constraints are enforced at the table level. That is, any value that you want to add violates any of the constraints that you've placed on the table, the entire row will be rejected. Now, at times you may want to add constraints to existing tables. The way you do that is with the alter table command. If you want to add a not null constraint, you have to use a modify clause. All other constraints you can do with an add clause. So most of the constraints are created using the add clause. But remember that not null can only be created using the modify syntax. Primary key constraint ensures that the primary key column does not contain duplicate values. It has to be unique, and it cannot be null. This is absolute requirement in SQL. The primary key has to be unique and has to be not null. You can't have a null primary key. You can only have one primary key per table. Here's an example. Alter table order totals, add constraint, order total primary key. The primary key is going to be the order number. And this succeeded because we did not have that. We did not have a primary key in that order totals table before. So adding this constraint, and it succeeded when we operated that line of code. Let's look at the primary key constraint for a composite key. Sometimes when you create a primary key, the primary key is actually a concatenation of multiple columns. And so for that composite key, we list the column names inside the parentheses separated by commas. That's the syntax, a comma between each column name. Or here's an example. Alter the table order items. We're going to add the constraint a primary key as a primary key, and it has a concatenation between the order number and the item number. There won't be any spaces or anything between them. It's just going to have an order number and an item number all together as one column, and it's purely for being able to give it a key. It's not something that you would use to display. A foreign key constraint requires the value to exist in the reference column of the other tables. Null values are allowed, so this enforces your referential integrity. It maps to the primary key in the parent table. So the foreign key in the child table maps to the primary key in the parent table. Here's an example. Alter the table orders, add the constraint. Here's a foreign key, O_C. It's a foreign key for customers. So this is orders and customers. So the O_C is for orders, customers. And it references the customers and the customer number. And this succeeded. So the foreign key is just simply a customer number. But it references, in order to create that foreign key column, it is referencing the customer number in the customers table. If we want to delete foreign keys, you cannot delete a value in a parent table referenced by a row in a child table unless you use the onDelete cascade keywords when you create the foreign key constraint. This is important. When you set up a foreign key constraint, you cannot delete a value in the parent table if there's a matching row in the child table, because then your data wouldn't make any sense. If you have the parent is gone, the children, normally you would want to ensure that they were either deleted beforehand or deleted when you delete the parent. So if you want the deletion to cascade, if in other words, you want to delete the parent, all the children are automatic. If you delete the parent that all the children are automatically deleted, then you use onDelete cascade. And that way, if you delete a parent, then all of the children will be automatically, those rows in that other table will all be deleted. And that'll keep your data integrity. So here's an example of how that works. Alter table orders, add the constraint, foreign key, order foreign key with customer, just like we did in the previous example. References the customers and the customer number just like before, but now we have onDelete cascade, and that way if we delete one in the one table, it will delete them in the other table so that we don't have dangling data that has no parent any longer. Anytime a customer is deleted from the customers table, we will automatically delete all that customer's orders from the order table. Unique constraint. No duplicates are allowed in the reference column. That's very simple. But the weird thing is it does allow null values. So null is not considered like a value. Normally you would think that if you were not allowing duplicates, that if you had multiple rows that had a null value, they're sort of the same value for that column. But that's one of the things that databases allow. SQL databases allow you to have null values even in a column that has the constraint to be unique. The check constraint. This is a very powerful constraint capability that allows you to be sure that that you don't get spurious data in a row. Let's look at the sample here, example. Alter table orders, and we're going to add the constraint for a check constraint. So it's called ship_CK for check constraint. And we're going to check that the ship date is greater than or equal to your order date, just like we talked about before. So we know that the ship date has to be equal to or later than the order date. And so we put that in as a constraint, and that way, anytime somebody tries to put in data that violates that, the row will be rejected. Not null constraint. This is the same as the check constraint with the is not null condition. It's only created at the column level. It's included in the output of a describe command. So if you want to be able to check what constraints you have, the describe command will let you look at them and see if you need to make any modifications or change your code. It's added to the existing table with an alter table modify syntax. So the not null constraint is the same as a check constraint, except that it just enforces the null condition. It can only be created at the column level. You may have seen that when you use the describe command, that the not null constraint shows up in the output. You can add it to an existing table with the alter table command using the modify keyword. So here's an example. Alter the table books, modify retail, not null. And let's look at what happens to our data definition. When we say describe books, the SQL server will show you this is what the definition of the books table. Here's all the columns and the constraints. You got a not null on ISBN and a not null on retail. One is because it's the primary key, and there's a not null constraint on the retail that we just added. In the next two examples, we're going to look at how to create constraints at the column level and how to create them at the table level. We'll create the same constraints on the same table, but with two different methods. We get the same thing done two different ways. At the column level, each constraint is put on at the time the column is defined. Here we are creating a table account manager with the account manager ID column as the primary key. The account manager name column has a not null constraint. The account manager eDate column has a default value of the system date, and the region column is constrained to be not null. Very straightforward. Just look at that syntax. There's nothing complicated about it. It's just a matter of following the bouncing ball. Now let's look at adding constraints during table creation. Here we're going to define the constraints at the table level. That means that we define all the columns first and then put the constraints on at the end of the table definition. We're going to create the account manager ID column and the account manager name column. The not null constraint can only be applied at the column level. So we have to put that one on the right after you define the account manager name column. Then we're going to add at the end of the table definition the constraint that the primary key is going to be the account manager ID, and we're going to add a check constraint for the region. We're going to say the region has to be one of the values north, south, east, or west. And just look at that code. It's very straightforward. We're creating a table, and at the table level, we have the not null constraint, but then later on we have the constraint about the primary key that we did at the column level. If you want to look at your constraints, you can display them and in the check constraints in the data dictionary. So when you select star from user constraints, so user constraints is a built-in function in SQL that allows you to see the user constraints, the constraints that you've put on that table. And so here are the three constraints are on there. You have a not null, the region has to be in that area, and then we have the primary key. So those are the three constraints that exist on that table. So Oracle keeps the table called user constraints automatically for you. You don't create it. If you want to see what constraints are in effect, all you have to do is select star from the user's constraint table for the table that you're working with, and you use the where clause to select the table. In this case, we can see that we have three constraints in the account manager table, as we just discussed. Enabling or disabling constraints. You have to use the alter table command syntax. So we're going to alter table account manager, and we're going to disable the account manager name not null constraint NN. So we're going to disable that constraint. We're altering the table and also to enable the constraint not null. So we just put it right back again, just to show that you can disable and enable a constraint. When you disable the constraint, it's gone temporarily. If we'd done a select star, we'd just shown or shown the constraints, we'd shown that it was gone, and then it's back again. We have to know the name of the constraint, which we can get from viewing that constraint from that user's constraint table like we did in the previous example. Dropping a constraint, you're allowed to change or modify a constraint, but in order to modify a constraint, you have to drop it first and then recreate it. The syntax for this is different for the different constraints. So when you're dropping the constraint for the primary key, just say drop primary key. You don't have to be more specific than that. For a unique constraint, you have to say which column you're applying it to. For all the others, you have to know the constraint name. You have to remember them. That's why we use conventions, so that we can keep track of the names in case we want to drop them later. So here's an example. Alter the table order totals and drop the primary key. Alter table books, drop the unique constraint on the title. And those things work. So if you looked at the alter table books command, we're dropping the unique constraint from the title. If we want to drop and recreate a constraint, you just look at the alter the table. The syntax is to alter the table, drop the constraint, the check, region check, and then we alter the account manager and add the constraint region check. And this time we changed the region in, we've added a fifth territory. And so in order to change the check command, we had to delete it and then recreate it. So that's how if you want to alter the criteria in your check statement, then you have to delete it and then recreate it. So what have we done so far? You should be able to explain the purpose of the constraints in a table. We should understand why we do them. We should be able to distinguish what a primary key is and a foreign key, as we've done so many times before. We need to know when a column you want it to possess only unique values, then the powerful check constraint and the not null constraints. We need to know when we should be using these and how they work with each constraint. We also remember there are two different opportunities to create the constraints, either at the column level or at the table level. We should be able to make primary key constraints for a single column and a composite primary key. So a lot of times your primary key is just a single column, like an ID number, like a social security number or employee ID or order number. But sometimes we concatenate several columns from tables into a single primary key, and that data is only used as a key. It's not used for output because it doesn't make much sense when you concatenate several columns together, creating a artificial value that's just used for data manipulation. And how to create a foreign key constraint, unique constraint, and check constraint. We've seen examples of all of these. We should know how to create a null constraint using the alter table modify. We should be able to include constraints when we're creating a table, either at the table level or at the column level, and how to disable and enable constraints, and how to use the drop constraint command. And let's go on now before we finish this and look at our assignment so you can kind of get an idea of what we're supposed to do. Here's the text of your assignment. It says we're supposed to write commands VS Code using the instructions below. We're going to create a new table called writers that contains the author ID, last name, first name, and the ISBN, and the title of the book that each author wrote. So here it is, create table writers. That's what we're going to do. Here's the columns, author, last name, first name, ISBN, and then we also want to have title. And then we have the close parentheses and semicolons. That means here's all the columns, but we want to alter the table writers to add constraint that the primary key is the author ID. And we add a constraint, the foreign key, that we have the ISBN that references the books table with the ISBN. So this is a very simple assignment. Then there's another part to the assignment that I don't have in here, but there's one other thing that you have to do. But that's most of it. So I hope you're all getting along well. If you have any questions, please let me know and we will help get you straight. Good night.